Hiya there, folks. Root Beer here with question number 20 on our 2018 Grade 11 Fermat paper. We're continuing right along. This is the last question in Part B. And what has it got for us? For how many positive integers x is x minus 2 times x minus 4 times x minus 6 all the way up to times x minus 2016 times x minus 2018 less than or equal to 0? The product on the left side of the inequality consists of 1009 factors of the 4. They didn't used to have to say this. It's obvious that that's what they are. It's even numbers is your pattern. You don't have to spell it out for us. It's a grade 11 contest, for crying out loud. Alright, less than or equal to 0. So what I want to do is break this into two parts. The equal to 0 and the less than 0, because the equal to 0 is going to be really, really easy to solve. Now, if you're having trouble with something like this, you might want to, say, look at something like this and answer a simpler expression. And I think we could probably find some patterns if we did something like that. But I'm more tempted just to jump straight to the answer, because I think it's already a pretty approachable question. So when is it equal to 0? Well, you've got a polynomial here, and it's already factored. So x equals 2, 4, 6, all the way up to 2018. Now they tell us in the question that this is 1009 factors, and so it's going to give us 1009 solutions, but you could figure that out because it's every other number. Divide 2018 by 2 and you get 1009. So that gives me 1009 solutions. Now how about this being less than 0, because less than or equal to 0, we already did the equal to 0 case. Well, we've got factors here, and x has to be an integer, right? For how many positive integers x? So we've got x being a positive integer, so these are all going to be products of integers and things like that. Now, suppose I did something like put 5 in here. Suppose I did something like x is 5. Just as an example, we'd have 5 minus 2, 5 minus 4, 5 minus 6, and after a while, they're all going to be negative terms. All right, you'll get 3 times 1 times minus 1 times minus 3, and you can sort of see it'll go minus 5, then minus 7, all the way down to minus 2013. Okay, so depending on the x value, some terms will be positive up to a particular point, and then afterwards they'll be negative. Okay? This was true up here, except one of the terms would eventually be 0. And so it would be positives, a single 0, and then some negatives. But we're not dealing with zeros anymore. We want specifically less than 0. So we'll have some positives and then some negatives. The number of negatives is going to determine whether or not we're positive or negative. If you have an even number of negatives, then the answer is negative. If you have an odd number, an even number of negatives, you'll get a positive answer. If you have an odd number, you'll get a negative answer. So how many do I have here? Well, I've got 2 positives, and that means 107, because we have a 1000, it's not 107, 1007. Because we have 1009 factors, so take away 2, you have 1007 factors that are negative. Doesn't matter what their numbers are, they're negative 1007. An odd number of negatives means that we will in fact be negative. Okay, so now we think about that. What numbers do I have to plug in here to avoid zeros? Well, what positive numbers do we have left? So x could be 1, or 2, or 3, or 4, or 5, 6. I don't know why I wrote 6 there. Or 2016, 2017, 2018, 2019. It could keep going. Now, the equal 0 case has bumped a bunch of these off. Notice that if I plug in 2019, 2019 is too big, so I'll get 2017 times 2015 times 1. This will be positive. In fact, anything beyond this is too big. It's going to be positive. So this leaves 1, 3, 5, 2017. So for the negative case, we're looking at numbers that look like 2k plus 1. I'll say 2k minus 1. For k being greater than 0. Okay? So what happens when I plug that sort of a number in? Well, I'll get 2k minus 1 minus 2, 2k minus 1 minus 3, all the way up to, I'll plug in 2k minus 1 into the 2k minus 2, and then the next even will be 2k minus 1 minus 2k. And this is where things are going to start to become negative. Okay, because we'll get 2k minus 3 and 2k minus... Oh, this should be a 4. So 2k minus 5. All the way up to, so this one here turns into a 1, and then times negative 1. And then all the way down, and then so then it'll be negative 3, all the way down to whatever 2k minus 2019 is. So, again, to figure out if this is negative, we need to know, well, how many odd, or not how many odd, how many negative terms there are in my product. Well, how could I possibly figure that out? Well, there's 1, 2, 3, all the way up to k minus 1, and then here's the kth factor here. So there's k minus 1 positives. And I realize the yellow probably isn't very clear, so let's go over it in purple. Right? We're just doubling it to figure out what we're subtracting off. So this is k minus 1. The kth factor in my product is the first of the negative numbers. Okay? So if k minus 1 is even, then that means an odd number of negatives. So if k is odd, then the product is less than 0. Okay, so once again we go back to our list of numbers. 2, not 2, 4, 6. We had x's 1, 3, 5, 7. These were the ones left to deal with, all the way up to 2015, 2017, because we already remarked 2019 is too far, and the even numbers we already know will make the product 0. Okay, and so this is 2 times 1 minus 1. This is 2 times 2 minus 1. All the way up to, this is 2 times 1009 minus 1. So the k value needs to be odd. So we have, let's say, 1. So 1 will be 1, then 5, then 9, all the way up to, and there will be an odd number of them. How many of them? Well, we're going to have, how many odd numbers between 1 and 1009 inclusive? Well, from 1 to 1008 is going to be 504 odd numbers, and then 1009 is your next one, and it's odd, so 505. So we had 1009 integers make the product 0, plus 505 make the product negative. So we'll have 1514, and that I'm claiming is the answer and that's right in the middle there. That's C. Notice our answer is D and E. Make it that we should probably double check our work. Okay, I'm fine with the 1009 even numbers. Maybe just give a little double check. Is it odd numbers, and do we have 505 odd numbers? Because if it's not odd numbers, if I've got it wrong, it's 3, 7, all the way up to 2015. We've done something wrong, and it should be 504 because the extra one at the end doesn't count. So a real quick check would be, well, 2017, is it going to be causing me a problem? So what would we have? 2017 minus 2 times 2017 minus 4, all the way down to 2017 minus 2016, and then the last term, 2017 minus 2018. This is the only one that will be negative, so yeah, 2017 is negative. It is every other one of these, and we have counted right. It is 505. So I'm happy with C. C is our answer. And that about wraps the question up. I will see you in the next video as we start Part C on our Fermat paper.